Welcome, everyone. Today, we are diving into a crucial evolutionary step for AI agents, agent skills. If you've been using tools like Claude Code or OpenCode, you know they are incredibly powerful. They can navigate your file system, run terminal commands, and edit your code. But as these agents take on more context-heavy and domain-specific roles in our day-to-day work, a pure, general-purpose approach starts to hit some limits. Think about onboarding a new engineer. You don't just point them to a code base and say good luck. You give them an onboarding guide, specific project rules, code style expectations, and step-by-step procedures for complex tasks like deployments. For an AI, we usually try to solve this with long system prompts. But prompts are fragile. They consume precious context window space, they are hard to compose together, and they force the model to load all instructions up front, whether they are needed or not. This brings us to a better solution, agent skills. At its core, an agent skill is simply an organized folder on your file system containing instructions, scripts, and resources. They act as modular, composable capabilities that your agent can discover and load dynamically. By packaging your domain expertise into these folders, you transform a general-purpose agent into a specialized operative tailored exactly to your organization's needs. But how does the agent know which skill to use without loading everything into context? The answer lies in a design principle called progressive disclosure. It works in 3 levels. First is level 1, metadata. Every skill folder contains a skill.d file wrapped with a concise YAML front matter, including a name and a short description. OpenCode automatically discovers these by scanning designated folders like .opencode/skills in your project or globally in your home directory. At startup, the agent preloads just this metadata into its system prompt. This costs very few tokens, but the agent now instantly knows what skills are available and when to trigger them. Next is level 2, instructions. When you ask the agent a question, say, extract data from this PDF, the agent matches your request to the PDF skill description. It then uses its standard bash tools to dynamically read the skill.md file from your file system. Only at this exact moment does the core procedural knowledge enter the context window. Finally, we have level 3, resources and code. As skills grow, cramming everything into skill.md becomes unwieldy. So, we bundle additional markdown files, Python scripts, or JSON schemas right alongside it. The agent reads these extra files strictly on a need-to-know basis. By combining file system access with progressive disclosure, we get an elegant, low-context, high-impact system. In our next segment, we'll peel back the folder structure and show you exactly how to author these skills perfectly. Stay tuned. Welcome back. Let's look under the hood and learn how to actually write a robust agent skill. As we covered, every skill starts with a skill.md file, and the most critical piece of this file is actually the YAML front matter at the very top. It expects 2 strictly formatted fields, name and description. Naming conventions matter. Using a gerund form, like analyzing spreadsheets or processing PDFs, helps clearly describe the capability. But the description field is the real hero here. This is the only text the agent reads by default to decide if a skill is relevant. Therefore, your description must be explicitly clear about what the skill does and when the agent should trigger it. Don't say processes data. Say extracts text and tables from PDF files. Use when the user asks to summarize, extract, or fill out PDF documents. Once the agent triggers the skill and reads skill.md, how do you write those instructions effectively? The golden rule here is to assume the model is already smart but needs procedural scaffolding. You need to set the right degrees of freedom. If you are asking the agent to perform code review, you have high degrees of freedom. You provide heuristics, like check for off-by-1 errors, but you rely on the model's intelligence to find the right path. However, if you are asking the agent to perform a database migration, you want 0 degrees of freedom. The instructions shouldn't describe the philosophy of migrations. They should just say, run exactly this script, python migrate.py-verify. Do not add any extra flags. As you author these instructions, your skill will organically iterate through an observe, refine, test loop. And here's a pro tip. Use the agent to build its own skills. Have Claude A work through an actual task with you. Once you succeed, ask Claude A to summarize its steps into a reusable skill.md template. Then, load that skill onto a fresh agent, Claude B, and ask it to perform a similar task. Observe where Claude B gets confused, go back to Claude A, and refine the instructions. Maybe Claude B missed a specific database table. That tells you your schema references need to be more prominent. This is evaluation-driven development for agents. Don't write 500 lines of imagined documentation. Build evaluations, find where the agent stumbles, and write the minimal amount of procedural knowledge needed to catch them. In the next segment, we'll dive deeper into how skills leverage executable code for more deterministic, bulletproof workflows. Welcome to segment 3. So far, we've talked about storing instructions in Markdown files to give AI agents domain expertise. But what happens when that expertise requires precise deterministic outputs? Large language models are incredible at reasoning, summarizing, and generating text, but they are surprisingly fragile when it comes to deterministic operations. If you ask an LLM to alphabetically sort a list of 1,000 items or extract data strictly following a complex JSON schema, it may hallucinate or fail entirely. It's also computationally expensive and painfully slow. This is where code execution changes the game. Agent skills are not just static Markdown documents. They can bundle executable code. In your skill directory, alongside skill.md, you can include Python scripts, Bash scripts, or JavaScript files. When the agent reads your instructions, it can literally run those scripts to perform tasks reliably and predictably. Imagine a skill designed to fill out a PDF form. Instead of giving the agent 10 pages of API documentation for handling PDF arrays in memory, we simply give it an instruction inside skill.md that says, to fill out the form, run Python scripts /fillform.py input.pdf fields.json output PDF. The agent determines the variables, formats the JSON file, and then executes the code flawlessly. This offloads the slow, error-prone token generation to a fast, deterministic Bash environment. This leads to a highly effective design pattern, workflows, and checklists. Because the agent can now interact with both scripts and its environment, we can provide literal checklists in our skills. For instance, Step 1, read all source documents. Step 2, run the Python analysis script. Step 3, if the script fails, read the validation error and rewrite the fields.json file. Step 4, rerun the Python analysis script until it passes. This run validator, fix errors, repeat pattern is the secret sauce for high-quality agent outputs. It's basically a test-driven development loop that the agent executes autonomously. By the time it presents the final output to you, it has already validated its own work through deterministic code execution. In our next segment, we're going to put this all into perspective by analyzing a real-world agent skill we use in production. Stay with us. Let's bring this to life with a real example. Behind the scenes, we use OpenCode and Claude Code heavily in our development pipelines. One of the best demonstrations of agent skills in the wild is the WebApp testing skill developed by Anthropic. Testing modern, dynamic web applications is notoriously difficult for AI agents. They have to spin up local servers, wait for JavaScript to hydrate the DOM, and interact with complex UI elements. To make our agents proficient in QA testing, we don't try to cram the entire Playwright documentation into the system prompt. Instead, we give them the WebApp testing skill. When you open this skill, the skill.md acts as a strategic playbook. It establishes a golden rule. Use the bundled helper scripts as black boxes to save context. For example, it provides a script called withServer.py. The instructions explicitly tell the agent, if you need to test a dynamic app, don't try to write complex async server lifecycle code. Just run Python script /withserver.py-server npm run dev-python your automation.py. The skill also enforces a deterministic workflow called Reconnaissance then action. The agent reads the rule that says it must never guess CSS selectors. It is instructed to first take a screenshot, dump the rendered DOM, identify the correct selectors, and only then execute the click actions. By combining these precise rules with executable helper scripts, OpenCode is transformed from a generic coding assistant into a sophisticated QA engineer. This is the power of composability. The agent reads exactly what it needs, when it needs it, and gets the job done accurately. Next, we'll wrap up by looking at how organizations are deploying these skills at scale. As we conclude, we must address the big picture. How do you deploy agent skills safely across an entire organization? Giving an AI agent the ability to execute code and modify system files is inherently powerful, but it also carries significant risk. A malicious skill can be destructive. It could tell the agent to ignore safety rules, extract environment variables, fetch malicious payloads from external URLs, and transmit your data externally. When deploying skills at an enterprise scale, security review and vetting are paramount. You must treat skill installation with the exact same rigor as installing arbitrary third-party software on a production server. Before giving an agent a new skill, admins must audit the entire skill directory. Are there raw bash scripts inside? Do they reference unexpected endpoints? Does the instruction text attempt to bypass safety constraints? Beyond security, we must manage the lifecycle of a skill. A badly written skill won't just fail, it can actively degrade the performance of your entire agent fleet. If a skill's description is too broad, like simply stating processes data, the agent might trigger it for totally unrelated tasks. Organizations need to deploy evaluation suites for their skills. Establish baseline performance metrics. Ask a set of representative queries to ensure the skill triggers when it should, but equally important, stays inactive when it should not. As your skill library scales, you may hit what are known as recall limits. The more skills you install, the harder it is for the agent to select the right one from its system prompt. The best practice is to start with narrow, highly specific skills, like formatting sales reports. Once you validate their performance, you can consolidate them into broader, role-based bundles like sales operations. By using Git to track versions, running evaluations before production, and maintaining role-based bundles, organizations can safely equip their agents with thousands of discrete capabilities. We envision a future where skills are the atomic unit of collaboration for agents. One day, agents will even observe their own behavior, write their own evaluations, and codify their own skills for other agents to use. Thanks for watching this deep dive into OpenCode Agent Skills. Check the description below for links to documentation, the skill cookbook, and everything you need to start building your own. See you next time.